y'all got those graphed?
Yeah.
You should have. So all you would do, and what we're doing today, I told you we're just gonna review everything. So I went through each little section that we've covered and just picked a few problems out of that to go over together. So all three of these are exponential growth functions. So all you would do to graph them is plug them into y equals in your calculator, just like it reads. And then go to your table and get a couple of points and draw it. Okay, but then you gotta state the domain and the range as well. Now, domain on these, it's been before Christmas, but we said the domain is always all real numbers. So the domain for all three of those would be all real numbers. The range is up and down, so you would have to find your up and down. So on the first one up there, let me get my marker working. I'm not gonna get real specific, I'm just gonna show you what they should look like. Takes it a minute when it's been on the charger. Oh, that was no good. I moved that up next. See if we can move it back. There we go. Alright. I need a white marker. So here on y equals 5 to the x, should just get something similar to that, right? Just, similar to that. So domain's all real numbers. So the range, it's above the x-axis, so your range, you would say y is greater than 0. Remember when we did that? Okay, on the second one, it's, should be something, comes over to the left a little bit more and goes up a little bit higher, maybe. Did y'all get something similar? I'm just rough drawing them, but y'all okay on that? So my domain's all real numbers. My range is the same, isn't it?
Is that 2.5 or 2 times 5?
Let me see what it's supposed to be, 2.5. My range would again have to be greater than 0. Now the last one, that's a -3 times 4 to the x plus 1 power minus 2. So there's a lot going on that one, so be careful when you type it in. But it should be something going like that. Did y'all get that? Uh-oh. Okay. So domain's all real numbers. Range, it's below this line, so your y is going to be less than, and that is -2. Yep. And you remember, we can get that from looking at the equation. Okie doke. So you'll be able to go to your y equals and graph things, and good on that? Okay, I'm gonna erase those. Alrighty, let's go to next. Come on, where's my? There we go. Okay, we did two different banking formulas when we did this unit. Our final amount was equal to our principal times 1 plus your rate divided by the number of times compounded to the nt power. We worked with that one. And then the other one that we worked with was the one that I called PERT, that had the number E in it. So this problem says you deposited $1,500 in an account, so there's my P. I deposited $1,500 in an account that pays 7% annual interest. So for my R, I moved the decimal point, 7% becomes 0.07. Remember this? Compounded daily. Okay, so it did not say continuous, so I'm not using PERT. I only use PERT if it says continuous. So it said compounded daily. So if it's compounded daily, what's my N gonna be? How many days are in a year? 365.
Yeah, what about leap years? Are we
Oh,
gonna put
come
that
on
in
now.
effect, or-
Find the balance after 2 years. So my T, my time, is 2 years. So we would say A equals 1,500 times 1 plus 0.07 over 365 to the 365 times 2 power. And we would do that in our calculator. Remember, it's money, so if you need to round to the nearest hundred.
You can get some for raising me.
It's stinking. When I came in early this morning, it smelled like bleach, so I was like, oh, maybe they really actually cleaned good today, or yesterday.
You got 6,074.6.
Well, that's not gonna be right.
I got 1,725.
That's it. $1,725 and how many cents?
38.7.
So 39 cents? That's it.
Oh, I put 0.7.
Oops, that would be a 70% interest rate. Whew. Good.
I like that.
Okay, so the next unit we did after that was still graphing, but it was decay functions. But do y'all need to practice putting those in the calculator too? Or I mean, it's the same as the first three we did. Just plug them in the calculator. Y'all good on that?
I'm good on putting stuff in the calculator.
Alright, so let's look at, make sure we can do one with the number e. So if we had y equals 2e to the negative x, and we're told to graph that, you are just gonna graph it in your calculator, but I wanna make sure you remember how to find the number e. So go to your y equals and type 2, and then to get to the e, it's second ln. Remember how to do that?
So beside the 4? Yes.
Yeah. So I think you'll get something, looks like that maybe?
Mm-hmm.
Okay, so your domain's all real numbers, your range is greater than 0. Okay, so we can type the number E in, that's fabuloso. Did you get it, Christian? Did you get the graph? Yep. Alright, so then we started learning how to actually evaluate some logs. So let me write 3 of these up here and let you remember how to evaluate these. Alright, so that first one says log base 5 of 625 and the directions say evaluate. So you could technically think about solving an equation and say, well, that's in log form, let's rewrite it in bin form and then solve the equation. That would be the longer way and the more difficult way. Easiest thing to do would be to hit math and go find log base and just fill in the blanks. Okay, so what do you get for log base 5 of 625? 4. Now, what about number 2, the one in the middle here, that's log of 0.001, so what's my base?
10.
So you can hit math and go to log base and fill a 10 in, or this is a time when you can just use the big log button on the left side of the calculator. What'd you get?
-3.
-3? Okay, and then what about the last one?
0.3 repeating.
0.3 repeating, or a third? Okay, so good on that. Okay. So then, the Alright, so let me write two of these down. Oh, I didn't read the directions, I was confused for a minute. Okay, the directions for these, I was wrong when I was looking a second ago. Directions for these two would say to graph. So again, to graph this, you're just doing it in your graphing calculator, but practice making sure you can go to your y equals and pull up the log base there in your y equals. So graph those and see what you get, and I'll rough sketch them for you here in just a second. And then we're gonna talk about the domain and the range.
That's,
Yeah, the first one's simple.
oh wait, never mind. I remember this. It's something different.
Yeah.
Couldn't we also put these in different? Well, no, it says graph.
Okay, so on the exponential functions, our domain was always all real numbers. On a log function, it's not. They're the other way around. Because on a log function, if you see how this first one right here looks, it's never gonna cross that line on left or right. So its domain, the x, because that's left and right, would have to be greater than 0. But on log functions, the range is your all real numbers. Okay, now on that second one, it was also hitting 0, wasn't it? So your domain would be greater than 0.
It
And-
was 1, 2, 3, 4.
No, not how, because it's gonna keep going down forever. It just looks like on your calculator that it hits it, but it gets so close to it and doesn't touch it, it's gonna keep going down forever. I'm talking about left or right.
Yeah, left, right, it says, it starts at 4.
You got it typed in right? Or am I looking at the wrong one? Could be either one of those things.
The right one?
Go get your weights. Don't put it in that parentheses. Did it bring the parentheses up? Is that what happened? Because what that's wanting to do is graph log base 3 of x and then scoot it down 4. But when you have it in the parentheses like that, that's moving it left and right.
I thought that was fine.
Um, That's weird. Weird.
It's doing the same thing for me.
Yeah, it pulls up the parentheses when you hit log base. Huh, that's a pickle that we're in with those calculators. I'll have to think, make sure on the test, if I need to adjust that, we will. I don't know, after it brings up the parentheses, can you just put the X in there and then move out of it?
Yeah, you can move out.
That's what you would need to do.
Yeah,
Move the
that's-
-4
we're
out
doing
of
that
it.
right now. Wait, put the X inside of it? we're-
Yeah.
Okay.
Yeah, it gives us that.
Good. Alright, so we fixed it.
Yep.
Good deal. Okay, then the next unit after that was our properties of logs, where we expanded and condensed. So here I've got log base 8 of 3xy, and we want to expand that. So what we see up there with 3xy, that means 3 times x times y. So we're gonna be using the product property, and the product property is friends with addition. So I'm gonna separate this into as many log base 8s as I can using all addition, because it's all product property. So log base 8 of 3 plus log base 8 of x plus log base 8 of y, and I expanded it. Remember when we did those
Mhm.
a while ago. And those were on your yesterday's work too. Okay, so this one we'll do the other way. I'll give you one expanded and we'll condense it. It says 2ln 3 plus 5ln 2 minus ln 8. And then we didn't really talk about ln a whole lot, but what ln means is a natural log. And that is actually, this is just a side note for you, ln is a natural log, it is log base e. So you could, but it's just faster since our calculator has an ln button to use it instead of log base e. But anyway, so this has got addition, we're condensing this down to one ln, so it's got addition, so I'm gonna use the product property. It's got subtraction, so I'm gonna use the quotient property. And then it's got big numbers in front, so I'm gonna use the power property. So all three of our properties are gonna happen here. So first thing I'm gonna do is my power property on both of these pieces. So I'm gonna have ln of ln of 3 squared plus ln of 2 to the 5th minus ln of 8. Now you can actually figure out what 3 squared and 2 to the 5th is if you wanted to. So let's go ahead and do that, right? If it were a variable, we couldn't, we would leave it, but 3 squared, that'll make that ln 9. 2 to the 5th, is that 32? 2 is 4, 2 is 8, 2 is 6, yes. So ln 32. Okay. So now left to right, first thing I see is that addition, and that's product property. So I'm gonna have the natural log of 9 times 32. And then minus, so that's quotient. Right? Now, here's what I want you to think about. That natural log of 8 what's 9 times 32? Let me think out loud with y'all, struggle with y'all. 288 divided by 8.
36.
Okay, so you get the same answer either way. So it's natural log of 36. What I was debating on, talking about.
Beta and Honor Society, please do not forget to get on and take your survey. Thank you.
Was should I do this 32 divided by 8 first, since it was just being subtracted from that, or should I multiply first? But addition and subtraction, you work left to right, so we ended up getting the same answer anyway. I'm glad that confused me for a minute. I almost had a brain fart, Kristen. Alright, so then the next thing we did was solve. That was the fun stuff. So I got 5 to the x equals 32. And then I got another one for you, log base 3. 2x minus 5 equals 2. Okay, so directions say to solve. So on that first one, 5 to the x equals 32. I know that's not a whole number, because if I put a 2, 5 squared is 25. If I put a 3, 5 cubed is 125, so I'm not going to get a 32. So it's got to be somewhere between 2 and 3. So I got to figure out what the heck can I do to get that number somewhere between 2 and 3. So what would our plan of attack on that first one be? Okay, it's in bin form, so let's write it in log form. That's exactamundo, Tyler. So I'll write log base 5 of 32 is equal to x. And so now you just plug log base 5 of 32 in your calculator. It's a coffee pot.
Could we also just press the log button and do like 16?
I don't
How would
understand.
that work?
How many decimal places?
2. I'm a 2 of hundreds. What do you have?
2.15.
2.15. I don't understand what you mean, Christian.
So that's log base 5. Could we do regular log, so it'd be 10, and then
Oh, I understand now what you're saying, but no,
I'm confused.
yeah. He's saying since 5 is half of 10, let's do half of 32 and just use the big log button instead of having to go to log base. But it doesn't work, so don't do that. But that's, I mean, you were trying
That's smart
stuff.
thinking.
Okay, so what would we do over here on this number 2?
Not what I was thinking.
In bin form?
Okay, good, it's in log form, so we'll put it in bin form. So 3 to the second equals 2x minus 5. So 9 is equal to 2x minus 5. Now what do you do to solve?
Add it up.
Yeah. 14 is 2x. So x is 7. Alright. And then the last thing that we did, was it Tuesday? Yeah, Tuesday this week was we wrote, I gave you data or points and we wrote the functions, so let's do one of those. Say that I'm an exponential function and I go through the point 3,8 and 5,2. I need you to write the function. So we gotta find what our A and our B are. This is what we did Tuesday. So what was our first step when we did this Tuesday? Right, this is our X and our Y, so we make new equations. Good. 8 equals AB to the third. And then 2 equals AB to the fifth. Now, when we did them Tuesday together, I was super nice to you every time, because I always gave you one that had an X of 1. This is a little bit tougher. Doesn't have an X of 1, but we're still going to do it the same way. Step 2 is to solve one of those for A. So which one you want to solve for A? Just want to do this one on the left, because that's what we always did. So divide, but instead of dividing by B, we're dividing by B cubed. That's okay. A equals 8 divided by B cubed. So then our third step was we took what A was and substituted it in for the A on the other equation. So we would have 2 equals 8 divided by B cubed times B to the fifth. And remember there, your B's are always going to reduce. So what does B to the fifth over B cubed reduce to? B squared, very good. So 2 equals 8B squared. Okay, we're going to have a fraction or a decimal here, aren't we? Because we got to divide by 8, right? So 2 divided by 8, I'm going to leave that as 1/4. Because I actually, even though it's a fraction, 1/4 is a perfect square. Because I'm going to undo that squared now by square rooting. When you square root a fraction, you square root the top and the bottom. So what's the square root of 1/4? 1/2. So there's our B. So now we got to plug 1/2 back here. So I got to do 8 divided by 1/2 cubed. So 1 cubed, 1 times 1 is 1 is 1. 2 cubed, 2 times 2 is 8. So you got 8 divided by 1/8. No. Remember when you divide by a fraction, you multiply by its reciprocal? No?
So you multiply 1/8 by.
Well, I mean, if you're going to do it on your calculator, just type 8 divided by 1/8. But it is the same as 8 times 8.
Um,
64.
So there's your answer.
I have like 3 numbers in my head. I know it's one of them.
1741 or
Set what? Oh, this one.
Nice.
Okay,
36,
so
48, 52.
I made y'all's, I told y'all this already, I think, but I made the test out, which I don't actually make it out, I steal it from a program, but I stole it from that program before Christmas. And I haven't looked at it again. So tomorrow we're gonna get our study guide and work on our study guide. And we'll see then if there's anything we need to shore up. But, I mean, this is every lesson that was in this unit. So most of it, like Holly says, calculator stuff. Y'all feel all right so far?
Hopefully,
All right.
find out next Thursday.